All right, so we're going to get into what I would consider a little bit tougher stuff here today. So we're going to look at what happens when you run into complex zeros in your polynomial problems. So in this case, this is a cubic function that's graphed here. So we got x to the third. That tells us that this has three solutions. Whatever the degree is, third degree, fourth degree, that's how many solutions the problem has. If it's third degree, it's going to have three solutions. The thing is, though, they might be real, they might be complex, they might have multiplicity, like we saw yesterday. So we're going to take all this into account. What we do know for certain is this has at least one real zero at 2. So when the question is, what are all the real and complex zeros? I know for sure x equals 2 is definitely one of my three solutions. What I don't know is maybe that spot has multiplicity 3, which again was that concept yesterday where we talked about if it has odd and even multiplicities and that kind of stuff from example 2. Or the other possibility is maybe it's got this one real zero and then there's two other complex or what we call imaginary zeros as well. So what do we do? How do we figure it out? What we do is we take the one zero that we know and we divide it out of this. So that's kind of what these steps down here are saying. So we identified the one real zero to be at 2. And now we're going to do synthetic division to divide the one real zero that we know out of this polynomial. So 2 is my 0. That's what I know. I'm going to take my coefficients here of 1, 1, -3, and -6. And when I divide this 0 out, what I'm left with is going to be the thing that I want to solve, the thing that I want to figure out the answers to. So we drop down our first number, and then remember the steps on this. We multiply and add, multiply and add, multiply and add. And we should expect 0 here. The reason why we expect 0 here is that we know this is a factor. We know that this was a 0 of this polynomial, so we should get a remainder of 0. What we now care about is this step 3. It says use the quadratic formula to find the remaining zeros. So this is the constant, linear, and quadratic terms. So this is x squared plus 3x plus 3. So now they're telling us put this into the quadratic formula, back from chapter 2, to figure out what those two most likely imaginary zeros are. So over to the side here, let us do that. So not a ton of space. Actually, let's just do it right up here. I think it'll be the best spot. So remember your quadratic formula. It's the opposite of b plus or minus b squared minus 4ac all under the root over 2a. So that formula, never going away. Got to know it. So I'm going to take my a is 1, b is 3, and c is 3 and put them into there. So I'd have -3 plus or minus 3 squared minus 4 times 1 times 3 all over 2 times 1. Now I'm going to work that out, and that should give me my imaginary zeros. So under the root, I have 9 minus 12, which is a -3 all over 2. And I can't break 3 down any further, but it is rooting a negative number, and therefore it is imaginary. So I'm going to get plus or minus I root 3 over 2. And those are my other two solutions. So as far as answering the question, sorry, I guess I should put it up here where I was actually putting my solutions. So 2 is one of my solutions, and then -3 plus or minus I root 3 over 2 are my other two solutions. So this is my answer to this problem. It had one real solution that I got easy from the graph, and then it had two imaginary, remember the plus or minus, that I got from doing all the work that went along with it there. And these are, in my opinion, about the hardest problem you run into in chapter 3. I think these have just a lot going on with them. You take the 1 0 you know and you divide it out, and then you solve the remaining quadratic with the quadratic formula in order to obtain those two other imaginary solutions for a grand total of 3 solutions. Fairly tough. Okay, what I'd like you to try is to try to do A on your own. A is extremely similar to what we just did. You can see it crosses at 3. That's what you're going to divide out, and you're going to try that in the quadratic formula. Just take a minute and work that out and see if you can get the same type of result as we did in ours. It'll take you a little bit. Okay, this one is a bit of a doozy, but start off the same way. You take your 0 you know, and you do the synthetic division to divide it out of this cubic. That leaves you with a quadratic. This quadratic equation goes into the quadratic formula and gets simplified to get the imaginary solution. If it's the quadratic formula simplifying part that you're running into trouble with, which these are tough sometimes, because you get -20 under the root here, You got to break that up into any perfect square roots. So I broke it up to 4 and 5 because 4 is a perfect square. And then I rooted those two values because square root of 4 is going to be 2 and square root of the negative 1 is going to be the I. And I got to here. And then I said, all these coefficients are divisible by 2. And I reduced it a little bit further to the 1 plus I root 5 over 2. This is a hard one. Like I said, these are what I would rate as kind of the absolute hardest question of this whole real chapter. But the key is to understand the process. You divide the 1, 0 that you know out of the polynomial, leaves you with a quadratic that you can solve with the quadratic formula. Maybe you need a little more practice with the quadratic formula or something like that to make sure you understand the simplifying of it. But that's the steps involved in a question like that. I don't want to worry about this one. This one's tougher than what we're really going to be seeing. If you're curious as to how this one would work or you really want to do it or something like that, you can. But this one, you actually have to do 2 divisions. So because it's to the 4th power, it has 2 real solutions. So you actually have to divide 2 out of this. And then you have to divide the negative 2 out of that. And then do the quadratic formula. So it's just like having to do this step 2 separate times. But again, I'm not going to worry about that one. We're not going to see really too many of those. But if you really want to try it out, you definitely can. Okay, so now we move on to the last type of question for today, which is these little story or scenario problems here. So this is interpreting zeros. This is actually not bad at all. So it says Acme Innovations makes and sells lamps. Their profit, P, and hundreds of dollars earned is a function of their lamps sold, X, in thousands. Okay. From historical data, they know their company's profit is modeled by this function. So they show the graph of the function. They also give the equation. Cool. Question is just what do the zeros of the function tell you about the number of lamps they should produce? So if you look at the zeros, this graph has 3 zeros. And since the X's, the inputs are how many lamps they sell, this 0 obviously doesn't make sense because this would be if they made negative 2,000 lamps or something like that. So this graph pretty much doesn't exist over here because that'd be producing negative lamps. And so the graph really starts right here. And so what this says is, based off this looks like it's at about 3, 4, 5, 6, 7, 8, 9, 10, and 10. And so what happens here is once they hit 3,000 lamps produced, they start making a profit. And then once they hit 10,000, they start losing a profit. And so when this says, what does this tell you about the number of lamps they should produce? If they go between 3,000 and 10,000 lamps, Acme will make a profit. Because that's the only part of the graph where it's in the positive section where they're actually making money. They're losing money here and they're losing money here. So really just a conceptual question, not exceptionally difficult in terms of understanding what's going on here. You just got to be able to interpret the graph and say, what do these 0 mean in the context of the problem? All right. The little triad problem on here says, due to a change in costs of materials, the function changes. So in this case, they don't give us the graph, so we're going to want to make it. So I'm going to go ahead and put this in a calculator. We'll take a look at the graph, and we'll see what we think. All right, so I did put this in the calculator like so. I then did have to adjust the window a little bit because it was on the standard window, it wasn't showing up very well. So I made my X's just go from 0 to 20, so from 0 to 20,000 lamps. And then the profit I have showing, actually I make this go a little lower just so we can see it. So I have up to negative $100 and $500 based off their units. So when I graph it, it looks like this. And so it's kind of the same idea. It's, from this x-intercept to this x-intercept is where the company's profiting. So I want to know those values. I can use the function on here, or I might be able to get them off the table. We can see. And it looks like we can. So at 1, or in other words, 1,000 lamps, they're at 0. And then also at 11 or 11,000 lamps. So in this case, it would be between 1,000 and 11,000 lamps. They'll profit. So very similar question. The tougher part on that is just make sure you can get the graph to come up and analyze it and find the numbers that you need to find. And this should be good for today. So the definite tougher part today, these ones, reading the graphs, I don't think are too bad. It's the ones where you have to do the synthetic division to get it to a quadratic and that type of thing. So you're going to see a few of those today. Those take some time. Expect those problems to be a little bit tougher on the assignment. And if you got help, or if you got questions or whatever, let me know. I can help you out.